We're on lesson 3 out of module 12, page 10, and we're talking about making inferences from repeated random samples. What is an inference? We talked about it like day 1, day 2. What is an inference?
Educated guess.
An educated guess. You might want to write that down again if you don't remember. An inference is an educated guess. What do we call that in science? An educated guess in science.
A hypothesis.
It's our hypothesis about what is going to happen. What do we think is going to happen? Now, we don't just pull an answer out of the sky because it looks pretty. Okay? It's based off of the data that we have collected, the information. We go off of information. So it says the results of a school-wide survey of all students at a middle school about renaming the school mascot to Bears from Grizzlies. So right now they're the Grizzlies. They want to rename it to the Bears. See what the students think about that. And the results are shown. So according to the school-wide survey, is the school-wide survey the population or the sample? Population. How do we know it's the population? It's the whole school, so it's school-wide. This is the result. 70% wanted it to be Bears, 30% wanted it to be Grizzlies. So are the students in favor of Bears or are they in favor of Grizzlies? Bears, okay? Since all the students in the school were surveyed, these ratios are the population ratios, okay? The students in a math class had an assignment to collect random samples of 20 students in the school and compare the sample to the population. The results are shown below. Find each sample ratio for those who prefer Bears and write it as a percent. Okay? So we've got our first sample here, sample 1. Now I had to look at this. It means that sample 1, there were 13 students who prefer Bears. When I first looked at this, I thought it was a ratio of 1 to 13 and it was throwing me off. Alright, sample 1, there are 13 people who prefer Bears. How can we set that up as a ratio? Because what is a percent? We've already done this before. What is a percent? What does a percent represent?
How much of the population is
Part over whole. Part over whole. A percent is the part over the whole. When we've gone to find a percent, what strategy have we used before for percent? The percent box. When in doubt, put it in a box. Do you remember your labels for a percent box? What always goes in this box? Oh, it's either is and of or part to whole. We're talking about samples. How many children or how many students were in this sample as a whole?
13. Oh, no.
Collect random samples of, so that's our whole for our sample. We care about how many prefer Bears. Well, according to our survey, how many people preferred Bears?
13.
13 out of 20, which is what percent? So solve your box. X gives me 65%. That's one way, or the way we did it in lesson 2 is we did 13 over 20 and we converted it to a percent, which would still give me 65%. Either way works. All right, in sample 2, 16 students prefer the Bears. So we want to change that to a percent so that we can, it's easier to compare percents than it is to fractions, because our goal is to compare this number to the bear mascots. So in sample A, we got 65%. This is a sample. How much was the population that liked bears?
70%.
Are we close or really far away?
Close.
We're pretty close, within 5%, right? We want to see, is sample 2 the same way? Well, we could compare it as a fraction. We could do 16 over 20. But it's just easier to compare it in the form of a percent. So I could put it in a percent box. Part to whole 16 over 20. Or you could leave it as a fraction, convert it to a percent, and what do you get? 80%. Is that relatively close or far off?
Close.
It's close. I mean, how far away are we? 10%, right? You want to be roughly 10% away. Now, when you get more than 10% away, that's when you start getting a little wobbly. You can think about it as far as your grades, right? Each, like you're talking about A, B's, and C's, and people don't know D's. But in A, B's, and C's, how many points are between each letter grade? 10 points, right? If you have a 90 or if you have 100, what do you have? An A. But if you have an 89 compared to a 95, what do you have? A B, right? So you gotta look about it that way. You can think about it that way. As long as it's 10% in the range, you're relatively close. Now, when you get further away from 10%, that's when there's some error happening. All right, so you find sample 3, 15%. Not 15%, but 15 students prefer bears. What is 15 out of our total as a percent? What did you get?
75%.
So how do these 3 samples compare to our population? The results from our population. We've got 65, 80, and 75. What was the original percent? Original ratio? What was this is the population. And these are the samples. And we care about the bears. How do our samples compare to the population?
They're all close to 70, or they're all close to what their population is.
They're all, you're just looking at the numbers, y'all. 70 and 65. How far away are those two from each other? 5%. 80 to 70 is what?
10%.
75 to 70 is?
5%.
Are they all relatively close to the population? Yeah, so could we say that they're relatively close? That's all it's asking. Because if you look down here at part D, it says, do these sample ratios support the findings that 70% of the entire school population prefer the mascot named bears? Do these align with this?
Yeah.
Yes, that's all it's asking. If it's close, then it's valid, which means it's good, it's legit. If it's not close, it's bad. Something went bad with your population or something went bad with your samples, but it's going to mean you need to redo it. Okay? So, do the samples? Yes. The samples are within 10% of the population ratio of 70%. Period. Does everybody understand how we got to that logic? Can you see how we got there? Even if we average these three together, how do I find the average? You do it every week with your homework.
Yeah.
So 65 plus 80 plus 75. And then divide that sum by 3. What do you get? 73. Is 73% is the average close to the population? Yeah. Okay, that's another way you could do it. Alright, flip the page. This is where it gets fun. Yay.
That usually means that.
Alright, you get to now do the sample. We already have the population information. You get to go verify, okay, the population by creating your own sample. Okay? So a bagel shop offering regular or toasted bagels makes the claim shown. Oh, it's not shown. I need to go find it. Alright? Use each method to explore how much variation, how far apart can be expected from a sample. So, we're going to construct a mock population, and we have already placed 60 red pieces of paper in the brown bags and 40 blue pieces of paper in the bags. It is very important that you keep all 100 little pieces in your bags and don't get them mixed up. Okay? So what you're going to do, everybody has a brown bag with a number on it. Okay? Your little pairs have brown number in bags on it. That's your sample number. What you're going to do is you're going to draw one out. Is it red or blue? Okay? If it's red, put a tally mark. If it's blue, put a tally mark. So like if I'm bag number 3, I'm sample 3. And I would start tallying it. Okay? Once I draw it out, tally it, you have to put it back into the bag, shake the bag up again, then pull another one. Record it, put it back, shake it, pull another one. Does that make sense? How many times are you doing that? Select 10 randomly pieces. So you're doing it 10 times. Okay? It should not take very long for us to do this. Like maybe 2 minutes. Okay? So get your partner, shake your bags. Y'all are responsible for doing 2 bags. Or how about this? How about y'all 3 just do 1 bag, and James, you go and Jacob, and Kaylin, and Ashton, you do it. Okay? Alright, so y'all are responsible for both bags.
So we do both bags?
Yes. Alright, 2 minutes.
Whatever number's on the bag, that's that number on the graph, you put the tally on it.
You and your partner are recording it on your paper. Alright, are we done? Have we done? Alright, finish that real quick. Who's still sampling over here? Y'all still sampling? You only have to do it 10 times. Only have to do it 10 times. Your sample is sample 2. So under sample. No. Right. Count how many did you get already? So put 4 under 2. And then how many That's probably my bad because I didn't give the best. Alright. So let's see. Alright. Sample 1. Who is sample 1? You guys over here. So y'all are going to now take their samples and record it on your sheet. Okay? So, Jacob James, how many red pieces did you pull?
6.
6 red. And how many blue?
4.
Okay. So then what we're going to do is we're going to take this. How many total pieces were there?
10.
10, right? We care about the sample of red paper. So we want to make it a ratio of 6 to 10. And then we're going to convert that to a percent. So what is 6 over 10 as a percent? 60%. Okay, and then we can write it up under here. Alright, sample 2. How many reds did y'all have?
We had 7 and 3 reds.
3 reds. How many blue?
7.
7. So we're going to set that up the exact same. We care about the reds. How many reds do they have over there? Total. We're setting it up as red over total. So they had 3 reds out of how many times? 10. So 3 over 10 is what percent? 30%. Alright, sample 3.
We had 4 red and 6 blue.
Okay. So it'd be 4 over 10, which would be what percent?
40%.
Alright, and then sample 4.
And then we had 7 red papers and 3 blue papers.
Which gave us 7 out of 10. Everybody know what percent that would be?
70.
70%. Okay. Alright, sample 5.
37. Yeah. 3 reds and 7 blue.
So how would we write that as a fraction?
3 over 10.
Which is 30%. You're going to do this exact same thing on your homework tonight. Okay? It's the same way. Alright, sample 6.
We had
sample 8.
We have 6 grades before 3.
We had the opposite, didn't they? Which would be what percent?
60.
Alright. 9.
2/8. 2 red.
2 red, 8 blues.
Yes, ma'am.
See, like, how did you get those numbers?
Because
Like
they pulled it
everybody.
10 times, and they got it. They pulled red 6 times and blue 4 times.
So like, everybody's like,
So they were sample 1,
yeah.
and they did it 10 times, and they
Okay.
recorded their answer. They were sample 2, and they recorded their answer.
That was the problem. Okay.
We did it correctly, guys. Alright, what did you say again? 2/8?
Yes, ma'am. 2 red and 8.
Ooh, y'all are real different over there. Y'all sure y'all mix your bags up real good? Alright, 2/10, which would be what percent? 20%. Alright, and gentlemen, last but not least, sample 10. Ooh, they were 50-50. Which would be what percent? 50%. Does everybody understand how we got as a fraction and how we changed it to the percent? Okay, because that's what you're going to have to do on your homework twice tonight. Okay? Can you do that? Okay. So now what we're going to do is we're going to take this information and we're going to plot it on a dot plot. These lovely things called dot plots. If it's called a dot plot, what are we going to use? Dots. Y'all, math people are very literal. Okay? We love it. Just keep it simple, to the point. Okay? So, we're looking here, because look down here. It's in what? Percentages, right? So we're not plotting the fractions, we're plotting the percents. So I've got a 60%. I'm going to come over to 60, I'm going to put a dot. I'm going to come over to 30, put a dot. 40, dot. 70, dot. 30, 40, 40, 60. These random people over here that are a 20 and a 50. Make sure I got all 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So when we look at this dot plot, okay, where's the majority of your data at in this dot plot? Around 40%. Like there's this whole little cluster around in here. Okay? So what I forgot to put on your note sheets, which you can add up here, is that 60% prefer toasted bagels. And toasted bagels represented the red represented toasted and the blue represented not toasted. So when they sample, or when they did a population, they got 60%. Based off of our samples, is most of the data around 60%?
No.
Not really, is it? I mean, it's somewhat close. Did we have some people get 60%?
Yeah.
And we had some people get real close to 60%, right? But a majority had 40%. What do you think could have happened there?
Can you change your mind?
You could have changed their mind. What else could have happened? Like based off of like their results versus what you just did.
They could have got more food.
Well, you all had the exact. Y'all all had exactly 60 reds and 40 blues in your bags. Your bags were all the exact same.
Because it was random. So.
It was random. It's not going to be exact. What were you going to say, Olivia?
There was more blue.
We only had 40 pieces of blue.
Oh, there's more red.
There's more red, so we should have gotten more red choices. Why do you think we didn't get more red choices?
Because it's random.
I mean, it is random. You could have, some people, could have been the way I put the pieces in the bag. Some people may not have mixed their bags up really well. They may have had just red pieces sitting on the top or blue pieces sitting on the top. Okay? So, anything could have happened. Were we close?
Yeah.
Yeah, but we could say a majority of the data is clustered. What does the word clustered mean? What is a cluster? Cluster means it is grouped around. And where did we say the biggest group was? What was it clustered around? Was clustered around 40%. Which is about 20% away from the population. Alright, flip it over. You got two more. They won't take long. Alright, a company manager takes a random sample of 20 employees. So what's the total for the sample? 20. That's our whole. And finds 16 employees prefer day shifts to night shifts. Is 16 our part or our whole? Part. Does this support the claim that 75% of the employees prefer day shifts? How can we compare these two? Right now we've got a ratio, right now we've got a percent. What could we do to compare them better? Change both of them to a percent, right? We already have 75%. We want to know what percent is 16 out of 20. So what is 16 out of 20 as a percent? Huh? 80%. How does 80% compare to 75%? It's 5% away. Is that okay?
Yes.
So does this support the claim or does it reject the claim? Is this close to this? Yes. So if they're close, it supports the claim. Now what we just did, we were far off, right? We were 20% off. So did ours support or reject?
Reject.
Rejected it. This supports it. With repeated samples, is the average of sample ratios more likely to approximate the population ratio than the single sample? Is it better to do more than one? Are you going to get a better answer if you do multiple samples versus one sample? Yes, because if we only looked at sample 9 where they got 2 out of 10, is this a good picture of all the other samples that we just did? No, this is one of those crazy fluke examples. I'm glad they did that. Alright, so we can't just look at one, we need to look at all of them. It'd be like me looking at your test scores and only picking the lowest score and judging everybody based off the lowest score. Is that fair? No. Okay? Because that person could have had a bad day, they could have not done their homework, they could have not paid attention. Something could have happened, right? It's not fair to judge that off of everybody else. So, more samples, the better. So what you got for homework tonight is the on your own section. So you've got this, and this. Now, you're not going to put this into peer assessment because what's going to happen is when you get to here, number 4, all your answers are going to be different because you're all going to get different samples. Number 4 is just like what we just did. Okay? You're going to have your own bag. The only difference is you have to do it all 10 times. You ain't going to have friends who can help you break up the sample. Okay? Unless we can cut your numbers out quick and we have time to share during bearing time what you got as your samples. You could do that as an option if you want to. Okay. For this one, number 3, what you have to do is you have to go through each sample, sample 1, and you need to tally or count. What I did is I circled all the ones that were 1 through 65, and I put a check mark on the ones that were 66 to 100, and then counted them up, because this isn't a very big space for tally marks. Does that make sense? Okay, but you're going to do this table the exact same way that we did this over here. Okay, except your total this time, well, it's out of 10 still. So it would be your ratios of 1 to 65 out of 10, and then you're going to change it to a percent down here.
You said it was these two?
All right.